What's up, everybody? Welcome to Flux Harmonic. I'm David Wilson, and we're back today with another live stream where we try to build something cool from scratch. And this stream is no different than all the others, I guess, in that we're going to be continuing working on the particle system that we started building from scratch in the last stream, with the purpose of adding new features and then maybe implementing a few more effects in the game with it. So let's see. I don't have any updates this week because I haven't really been having much time to work on things in my free time over the last a couple weeks maybe. And this weekend I was gone on vacation, so that's part of the reason why I'm late right now. Is we came back a little while ago for coming back for our week and getting back to work and everything as usual. So I'm happy to be back though and getting back into it. So before I get into it, let me say hello to a couple people who showed up early today. First is Luis, who couldn't stay. Thanks to Luis for being here though and leaving a like, and then also to Robert. So now it works. So now what? In the last stream, we did manage to implement a working particle system from scratch and verified that it worked by adding a ship booster effect for the player ship in the game we've been working on called Siphon Break. So today we're going to expand on the implementation and add a few more features that will make it a little bit more interesting, and then add specific effects to the game using those new features. Basically a few things that I've got lined up that we can talk about in just a second. But if you are interested in the code that we've been working on so far, I've left links to all three of the relevant repositories that you can find on GitHub. If you go look in the description of this stream or the video recording, you'll see the link to the show notes, and you can go check those links out there. So let's actually just quickly take a look at what we've got so far since last time. I'll jump over to the game and run it really quickly. And let's jump into the game, and you can see that there is a particle effect behind the ship, basically just like a ship booster, but after some amount of time it crashes, so we'll talk about that in a minute. But we do see that it works up until the point where the game crashes. Now the crash doesn't have anything directly to do with the particle system, it's more of a garbage collection issue, but we will work on that first today. So the tasks that we have at hand. First of all, we need to fix that garbage collection crashing issue. Like I said last time, what's happening here is we've implemented the particle system in the C layer, not in the mesh layer. And if you haven't been following what we've been doing so far, we've got two programming languages we're working with. One is C, just a traditional classic language C. We have to do all the memory management yourself. And then I've also written my own language called Mesh, which is based on Scheme. And that one does have a garbage collection layer. But since we've written the particle system, hey Ashras, I'll tell you that in a minute. Since we've written the particle system implementation in C and the objects are all in C, we have to add the ability for the garbage collector to mark the particle system objects as GC roots. So I have a strategy on how to do that. We're going to try to put that together as quickly as possible so that we can get past that issue, and then we'll continue on to the next issue, or the next task, which are adding color interpolation for particles. So basically you can start at one color and then fade to a slightly different color. We may or may not do that one because it could be a little bit more complicated, but we'll see. We'll definitely add opacity interpolation, so fading, basically. You can fade out a particular particle. Adding an explosion effect when a ship is destroyed. That one's pretty obvious. If you blow up a ship, it should have an explosion effect. Add a speed boost effect, so basically whenever you have the speed boost pickup, you should have some kind of little green sparklies around you to let you know that you can go faster. And adding a burning effect for heat waved enemies. So we added this heat wave item or pickup in the, maybe was it 2 streams ago, where you can pick up an item and then use it later, and it basically causes all the enemies on the screen to catch on fire effectively. So we need to add an effect that shows them being on fire so that it is visible. Also, I'm thinking about adding particle effects for enemy ship boosters. I mean, that's a pretty obvious thing to do since the player ship has it, but we'll look into that in a little bit and see whether it's worth doing. So Ashra says, ASAN crashes, color me interested. Well, it's not ASAN that's crashing. Let's see, what does it say? So this is just saying that there is a, let's see, heap use it after free. And that's because the garbage collector is freeing the objects that are involved with the particle system because I'm not marking them as part of the mark pass for the garbage collector. So that's what we're going to be trying to add really quickly. So I did actually try to add something for this in the past, but it wasn't working. And I think some of the fixes I did after Ludum Dare may have made it possible to move past this problem. So let's actually go take a look at that code really quickly. I'm gonna go to siphon break. Nope. Which folder is it? Siphon break. There it is. Cool. And then into deps, meshling, compiler, source. Let's see, was it in object.c? Yeah. So in this file, there is a free function, object free. And when we have any object that is an object kind pointer, this is a pointer to some random memory from the C layer. We construct some object and we return a pointer back that's wrapped in mesh so that it can access it. Now, there is a certain type of pointer you can create which has extra information, like a function that will allow you to free it, but we will also need a function for marking. But we haven't gotten to that part yet. But first of all, let's at least see if we can get the freeing working, because this was crashing in the past, but maybe we can get it to where it doesn't crash anymore. So if I uncomment this and comment out that free there, we can take a look at this to see that the pointer struct has a type field. And if it's not null, then we need to check to see if it has a function for freeing the object that the pointer points to. And if it does have a free function, we call it using the pointer to mesh memory and also the pointer itself, the actual pointer in memory. So I'm not sure. Let's see. Do I still want to do? Right. Okay. So if it doesn't have a free func, then we just use normal free function on the pointer itself, and then we ultimately call free on the object pointer that wraps that native pointer. So let's run this now and see if it actually gets somewhere. In fact, what I probably want to do here is, oh, well, I think I need to do something else first. But we are going to add a print statement here. So printf, let's see, about to free native pointer. And then that will tell us if we hit this line of code. Let's see. So there's another function I have, make pointer type. So if I find usage of that, make pointer type, I do have something somewhere. It may not be, oh, right here, process. Okay, so I do have that here. So we have the mesh process type struct that describes the type. And it basically just says what the type name is, how do you describe it, and also gives a pointer to a function, the free func. So we're going to do the same thing for the particle system, excuse me. And then, let's see, particle.c. Up here towards the top, I'm going to drop this in, and this is going to be the subst, what do we call it? Particle system, particle source. So subst particle system type, and then we're gonna have the subst particle source type. All right, so, whoops, all right. So now we can add names for that. So subst particle system, I guess we can just call it like that. Or just particle system, how about that? And then we'll drop in particle source here. And we do need functions for freeing. We're also going to need functions for marking, but that type doesn't have those yet. So we'll get to that in a moment. Now, interestingly, yeah, okay. Marking may not be 100% necessary unless a struct contains a pointer to another mesh object. So yeah, we'll deal with that if we have to. We may not actually have to deal with that yet. Okay, so I need to add functions for these. Let me go look at process.c free func. Okay, I just basically have it here. I can drop this. And I think I've got the wrong type, in fact. So this should be a particle system free func. This should not be object. This should be void, I think. And then we're going to do a cast here. We're going to cast this to subst particle system, subst particle system, because what we're doing is we're passing, let's see if we look at object.c, we're passing in, let's see, let's go back to free, right around here. So we're passing the actual pointer into the free func. I guess the question is, do we want to do that or not? There's really nothing that's useful in the object itself. However, this may be something that we would want to do, but we'll change it later if we have to. For now, let's just assume we're going to pass in the object. I'm going to cast this to void. It's kind of not good practice, I think, to casting this to void pointers, but that's what we're going to do. Actually, I think the pointer itself is already void. Let me check that really quick. We look into object.h, object pointer. Let's see. Pointer type, pointer. Okay, so it is void pointer already. Fine. Cool. So can I just do that? Pointer. Cool. Put this here. Just, something to give us a little bit of readout of what we're doing. And then back into particle.c, we can, I'm sorry. I think I've got allergies these days, so that's why you hear me sniffing so many times. So, all right, subs particle system, obj, so we casted it down. Now we need to free it, but not only, well, let's see. We're creating pointers. Yeah, I don't think that the system itself should free the object. Let me actually take a look at this really quickly. So the particle system has a pointer of pointers, or basically an array of pointers, and everything else is just a normal object. So it doesn't really need this functionality, I think. Only the particle source needs it because it has a list of, well, no, it doesn't need that because we need to free this list of particles. So let's keep going. I think that we're doing the right thing here. So we need to first free the array, the sources array. So we're going to free system sources. So that's one thing we've allocated. Then we'll free the system itself. I think that's enough for the particle system free func, and we'll go here and say particle system free func. Okay, so now we can do the particle source free func. And do the same thing, source. And now for the source, we have a different set of things to free. We have the particle list, which I think is only going to be as big as, interesting. Yeah, okay. So I'm going to be as big as the maximum number of particles. Well, actually, yeah, that is it. So we have as an array, or is, okay, we've allocated it as an array, but it is just a contiguous array of subs particle structs. So we would just free the first address of this, and it should take out everything. Everything else here are structs that are not pointers, so we can just free the object itself. So how about we do that? So sources, particles, I believe. No, source particles. All right, subs particle particles, and we free the source itself. So that's a pretty good starting point. I think that should take us there, so long as it doesn't crash like it had been doing in the past. I got a lot of swigglies here, but I think it's because the language server is not really agreeing with me right now. What did I just do? No. What happened? I think I somehow deleted the first curly brace. Okay. All right, so that gives us the subs particle system type, subs particle source type. So make pointer. When we call make pointer, we're going to use make pointer type instead. And then we're going to pass a reference to that struct. So this is for the make system subs particle system type. So we're going to pass that in right there. And similarly, when we go to this one here, which is for particle source, we're going to do the same thing. Type, and then at subst particle source type. And I think that's good. So if we run this, let's see what happens if it actually crashes this time. We'll see pretty fast. I think we had an error. Unknown name subst particle system and line number 7. Okay, because I think that okay, I need to move these functions down because I'm defining them before the struct types I'm referencing. So let's do this. Drop them right here. In fact, I can move them to the requisite struct definitions. So if I go right here, I can drop this before the system definition. That seemed okay. Let me double check that. Nope, something's wrong. Too many arguments to function make pointer type. Let's see, what did I do wrong? So I need the pointer. Oh, okay, I did a mistake there. So make pointer type. Let's get rid of the true. Okay. Yeah, so that needs to go away. And there's also a return that I'm missing. Uh, 257. Unterminated list invoking macro object val. 76. That must be where it starts. All right, so. Oh, excuse me. I have a missing parenthesis at the end of the line. That time, maybe? Let's see. It's warnings, but warnings still means something could be wrong. Initialization from incompatible type. Okay, so void mesh memory object. Oh, okay. I think I need to change the, let's see if we go back to object.h. Free func, or free, what? Free pointer? Object free pointer. Yep. That's what Ashraz is telling me right now. And did I define that where in value.h? Let's go there. Object free pointer. There it is. Inside of which file is this? vm.h. Great. Okay, so object free pointer, and this needs to be void. All right, so thanks, Ashraz. All right, so we got that. I think that's all clean now. I'm not seeing any more complaints. All right, so if I press space, let's see if it crashes at some point. Okay, crash again. This could be for a different reason. Let's see. About to free native pointer, heap use after free. Now that's pretty interesting. Yeah, this is the point where we need to be marking things. Let's see. So the problem is that the system has pointers to sources. If we go back to particle.c, subs particle system has references to sources, but these are not actually references to mesh objects. So they may actually need to be references to mesh objects for this to work. And it's a little bit unfortunate because it means I have to do an indirection. But I could keep separate lists. I could keep one list of the actual sources so I don't have to iterate over the mesh array. And then I could keep the actual value list, which I could mark. So basically, let's see, value array. Sources, MSC. Yeah, I know it's not the right name for that, but that could work. Put that right there. I mean, technically speaking, I could just do that without having a separate subs particle source. But what we do need for this to work is we need a mark function. So if I go back to value.c, object, no, it's in VM, vm.h. So this function, object mark pointer, this really needs to be object free func pointer. Object mark func pointer. I'm going to call it that here because it's necessary. And in this case, we're going to say object because it will be an object. So it kind of implies that this one should take an object also, but we'll wait on that for a minute. So object mark func pointer, if we go to object.h, then we also need an object mark func pointer, and then mark func. And what this is going to do is let the native object participate in marking in the garbage collector. So if I go into, let's see, vm.c in the marking functionality, mark object. So there's a place where I'm looking at object pointer, I think. If it's not kind, object pointer. All right, so we probably need to start looking at object kind pointer, or at least, let's see, if it's not object kind is pointer and as pointer object mark func. Yeah, I haven't added that yet. Let's go back to object.h. So we have mark func here. That's the object pointer type. So where am I storing this information? Oh, we do have it under type. Okay, so that's there. While we're here, let's go back to object.c. Make, that's right. Okay, gotcha. Here we go. So back in vm.c, we're gonna check. I hate having to do multiple steps on this, but we're gonna have to, unfortunately. And so that could take care of it. Let's double check that I've got the parentheses right here. Ow. Okay. Right, so we're checking to see if the object kind is a pointer kind, it has a type, and it also has a mark func. That's the only case where we would want to add it to the gray stack, which is basically the list of objects that have things that need to be marked inside of them. So if we added a object kind pointer, then we're going to try to mark it. And where am I doing that check? I have a switch somewhere, maybe right here, darken object. Okay, so this is the place where we need to do it. So if I could look at, let's say, case object kind pointer, maybe I can double check that it still fits the same invariant. Object pointer, let's see, function, no, sorry, pointer equals object function. I think I just cast it or did something I didn't need to do there. Let me go back and fix that in a second. All right, so I'm reading the code above. At the same time, I'm processing Ashra's message and I'm getting distracted. So if pointer type and pointer type mark func, then we're going to call pointer type mark func with the VM and the object itself, and that's pretty much it. So that will allow us to mark that pointer based on the functions defined in its type. So Ashra says, does your garbage collector allow or use automatic defragmentation, memory reallocation movement? It does not at the moment. If it does, you either need pinned pointers or probably should get rid of the native source pointers if they're still in the system type. Yeah, you're probably right about that. But that's not a problem I have right now. It will be later once I have a little bit more elaborate GC scheme, if I add one. I don't know. So far, plain mark and sweep has been fine. But later I may need that. All right. So we've added what should be the marking functionality. So if I go back to particle.c and define a mark func, I can change this to object, and I'll have to cast this to object pointer equals, well, is that right? I mean, why not just take an object pointer directly? Since I already have one. I guess I don't need to. I'm not sure the right way to deal with this, because this could be a void pointer and it could just be I step into the object, so you don't need to do a separate unwrap. Yeah, let's start with that and see what happens. All right, so subs particle system. Now for marking, we need to call. Do I have access to this function? Let me see. Go to vm.h mark object. Okay, I can do that. So mesh mem mark object. What was the signature for that? It takes a VM and an object. So we're going to cast this to VM. And then we're going to pass in the object for the sources list. I mean, at this point, sources just kind of feels like it needs to be a value array. So I have a type for that. I just get rid of this. Let's try that first. Hopefully this doesn't take too long. Otherwise, we're not going to get to all the other stuff that I talked about doing today. All right, and then free. No, we're not freeing anything. We're just marking. So mesh mem mark object. Yeah, this is the only place we need mark because this is the only time we're touching another object that gets returned directly as something in mesh. So this is, we don't need to do this for the system as well, which is good. So mesh mark object system sources. I know I named it something else, but let's just go with this for now. I may need to cast that to object star. And instead of value array, this is going to be, what did I call it? If we go to the object.h array, make array, object array. Okay, so this will be object array. So I'm going to get rid of that. This will simplify things a little bit too. Well, in some ways. I can take that out. So if we don't mark it, then it will get freed on its own, which is fine. So this would mark that array, which is great. That should be enough. And this will free the system, which honestly, we don't even need a special free func at that point. We just need a way to mark so that the objects with pointers can be freed correctly, or even marked correctly. So now I need to change the existing code for sources to not do this. It needs to do something else instead. It needs to do mesh object make array. And that's going to be casting mem to VM. And I think that's it, right? Is that right? Make array. Yeah, there's no parameters to that. So we're just making an array. And once we've made it, we don't really even need num sources, so we can reach into sources for that, I think. Num sources. How many times did I use that? Okay. Let's take that out. System sources count, I think that's called. So that's kind of nice. I think this is actually not even a... Okay, we'll have to deal with that. Sources, yeah, this is a struct, so this needs to be a dot. Now, if I were to go into object array, yeah, this kind of sucks a little bit. The unwrapping of this. Because I have to go down into the objects even. So if I have a function for that, let's see. Subst pointers, sorry, subst particle source. particle system source. Then I'll give it the object array sources and then int index. So I just want to return the actual pointer at that location. And with that, I can say sources object. Yikes. Whoa, what did it do? Sources object values. Is that what it's called? Let me go to value.h. Is that right? Value array. Yeah, values. Not ideal, but it's what we have to do at the moment. I could leave things the way they were and do separate memory management for that struct array, which could be simpler and faster. Ashra says, but the marker text of VM, we only have a mem at the moment, though. Might need a second interface in mem.h. I have kind of a bad design right now with how the VM interface does double duty as mem, so I need to fix that at some point. Not ideal. All right, let's think about this for a second. Maybe I should just leave num sources in there. In the, we'll go back to particle. I'll tell you what I mean in a second. Object values, and then we're going to index that with the index, and then we're going to return that as a pointer, object pointer star, and then we're going to pull the pointer out of it, but we also need to cast that again. This is why I need to function for this, because it would be ugly otherwise. And then we're going to cast that to subst particle source star. After I save it, it should be prettified a little bit. Did I do this wrong? No. Why did it drop that on that next line? That's funny. Okay, so we're returning a particle source that comes from the values array and at that index. So hopefully that won't give us any trouble later. Sources bracket. Let's find all the places where we're using that directly. We're gonna have to fix that. Make system. So read in and process every particle source argument. So in this case, we can change how we do this and say mesh value array right. Is that what it's called? Value array right. Okay, so mem array value. Where is it? Mem, and then system sources, and then it was mem array and value, right? Yeah, okay. Then object val of args I, because we're just taking that object directly and adding it to the internal object array. Okay, that seems good to me. And then the other instances of sources I, we're gonna call particle system source system I, just to rip that out. Let's just copy that. So I'll do it again right around here. Subst particle source equals. Okay, then we're gonna do this. And we'll also say source here. Okay, that should work, but we'll see really fast if there's a problem. All right. I don't know if it's going to compile, but we're going to try to run it anyway. I also need to make sure that mesh build doesn't let you run. Yeah. Where was that at? I know I did something wrong somewhere. Yeah, okay. vm.c line 98. This does not need to be as pointer. This needs to actually just be a cast to object pointer star. Actually, we'll do this. Okay, so that should be fine. And then I also need to do the same thing here. So object, pointer star, and delete, 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 delete. All right, so that should be okay. Something else flashed by there. We're gonna quit and go back. Particle.c, line 54. Let's see. Oh, okay. We got to cast mem instead of VM. Fine. And then what else? Can't convert to a pointer type. Object array from type object array star. Oh, okay. So I need to change sources to a pointer. That seems okay. We'll start with this. Did I miss anything? There's an error. Can I convert to a pointer type? Array right. I think I need to make that a... Where was that? Particle C 76. This needs to be a ampersand. I think we're good now. Let's take a quick look. Nope, not good. Sources is a pointer. Okay, 224. Yeah, I messed that up too. So sources object dot count, and then sources count. Did I do that somewhere else? No, maybe not. Let's go back one more time. 76 again? That ain't right. Which one? Cannot convert to a pointer type. Argument 2. Don't understand. All right, so array right. Let me check that. Oh, maybe it's because I hadn't changed it right yet. Mesh value array right. It does want a pointer. Oh, wrong. Okay, I see. I am doing the wrong thing. Sources, do ampersand, sources dot, no, sources object. I think that's right. Cannot convert to a pointer type. Particle C77. Still the same thing, right? It's not right, is it? I need to cast that? Maybe I need to cast it. Yeah, I'm doing something wrong. Really wrong. Objects. Now, objects is a struct and not a pointer, so that should help. Once again, complaining. 77 cannot convert to a pointer type. Ah, is that okay? This doesn't need to be converted because it's already a value. Cool. And a few other complaints here. Passing argument 3 discards const qualifier. Okay, I don't care about that right now. Okay. Something else going on wrong. Invalid type argument of arrow. Yeah, so 149. This is struct. Values index, but is values an array? Yeah, it's an array. Okay. Cool, that should be okay. System sources is a pointer. Did you mean to use arrow? No. Where's that? It's 163. Oh, yeah. I was looking for that one. Sources objects.count. So object.count, that's also wrong. Objects.count. Here we go. Another little error flew by. Let's see what that says. 148. Yeah, I keep writing the wrong field name in here. That just tells you how consistent I'm naming my stuff here. Cannot convert to a pointer type 149. Which part? All right, let's check value.h. So this is, wait a second. Can't just make that an object pointer. We need to actually cast this or use as pointer, I think. And I need to dereference it because I need the value, because this is an array, or it's basically an array of values. So I need to dereference the value. This may not be right though. Let's see. I think it's wrong, but we're gonna find out fast. Yes. Okay. Getting it wrong consistently. Expected expression before token. Is it? Whoa. Why did that happen? My mistake. All right, no errors this time, but I got a feeling we're gonna get some crashes. Let's see what happens. Oh, immediately. Okay, heap buffer overflow. Doesn't sound good. Line number 148, right around here. Okay. So sources, we have objects.values index. Maybe it is this after all. No. Nah, it can't be right. I really need, let's see. Are you gonna give me something useful here? I'm waiting for the language server to tell me what type this is. I think it should just be a value. This should give me an error, I think. Well, let's see. It's definitely not care. Okay, so it's value. So this should be fine. But I think I'm putting this pointer on the wrong place. So this needs to go here. Yeah, as pointer, and then the cast goes on the outside. So maybe that's what the problem is. That's really an ugly formatting suggestion. Okay, seems okay this time. Let's try it. Ah, god damn it. So something I'm doing wrong. Objects equals. Okay, so that's wrong to begin with. Let's see. Sources equals mesh object array. Make array. We should have an array at this point. And then we write to it here. Yeah, that should be fine because we're writing to the objects list. Let me actually just print this out. Let's try this. I wonder if the array is printable at the moment. Let's just print out the account at least. Okay, so system sources objects.count. Try that. Array has 1 elements. Why would it be so early? I guess I'm doing that in main. Okay, so it does have something. So if I go back to particle system source, let's try the same thing here as well. I'm going to try to pull this out before we do anything. Subst particle source star source equals source. And then hold up. That's not right. It would just be sources dot objects. Okay. Try that. Come on. Nope, wrong. Okay, so I'm passing a wrong pointer here, I think. Particle system source. System. No. Wrong. Okay, so I think I'm getting the wrong thing here. So system sources. This is not right. This should be subst particle system. I don't know why it didn't complain to me about that, unless I missed it in the warnings, which it should have been an error in that case. All right, so system, and then system sources object count. System sources objects values. Okay, so this should be okay now, I hope. Cool, that's working. Now let's see if it GCs. Nope. Well, that's fine. At least we have a starting point. What did it say before the end? About the free native pointer? Sure. So, marking. Let's see, mark func. Let's see if it's actually being called. I may not be calling it correctly. Let's see, printf about to mark particle system. Come on now. I think it should put a semicolon for me, in my opinion. Let's see what it does. So it never tried to mark. But I wonder if it's trying to mark a particle system first. Well, it shouldn't try to free it though until it's finished with the entire process. So something is wrong. Let me think about this for a second. I'm going to go back into vm.c. All right, so if object kind is pointer and the type is not null and the mark func is not null. Oh, let me make sure I set that up because maybe I didn't. Particle.c, particle system type. I did not add mark func. Dot mark func equals particle system mark func. No, don't do that. Okay. Let's give that a run. All right, so it did something. About the free native pointer. I don't see it trying to mark anything. particle system mark func. And yeah, we would see about the mark particle system, so it definitely didn't get to that point. I can try it right here. If object kind equals object kind pointer, and object probably need to wrap that. Then I'll try to print something out here. So printf about, let's see, checking object pointer for mark func. I'm going to try to give it the mark func pointer address. Let's see, object pointer object type, and then mark func, and see if anything comes back. All right, so checking object pointer for mark func, that seems legit. That's an address. However, let me think about that. These structs don't get initialized to null by default, which is a little bit scary. Which means anytime I add something to that struct, I'm going to have to go update everything. Wouldn't it be zeroed out if it's statically defined? I hope so, but I don't know if we can trust on that. All right, so checking object pointer for mark func, about to write free native pointer. We didn't even get to the point where we call it. So I don't know if it ever gets added to the gray stack. So if object kind is object kind pointer, I'm just going to write it out, printf adding pointer to gray stack. Let's do this. Adding pointer to gray stack. Okay. That's interesting. Shouldn't be that many. And once it did get added to the gray stack, we shouldn't be freeing things yet because we need to still process everything. So let's check the switch for mem darken object. Let's see, printf about to mark pointer. Or let's say about to darken pointer. Let's see what this does. Okay, so we did get to a point where it's trying to darken the pointer. Let's do this just to make sure. And did we pass the right thing? No, we did not pass the right thing. That's part of the problem here, I think. We need pointer. We need to pass that, so maybe that's what's going wrong here. Adding pointer to gray stack, but it never gets to this point. So if pointer type and pointer type mark func is not null, I don't know. I think that should be equivalent, right? I think I did something wrong. My logic is backwards. So in come on now, gray. Right here. So if object kind is not object kind keyword, so we're excluding the types that shouldn't go in this list, but here I'm checking to see if it's exactly the thing that I want. So yep. So Ashra says, yeah, yes, pointer and pointer is not null are the same. Okay, so here is the problem. So object kind is pointer. So I'm checking to see if it's a pointer first, and then I need to check if it's either null or if the mark func. Oh, hold on. If the type was it, hold on, wait. All right, so it originally was that. Good. Okay, fine. Okay, so if type is not null and mark func is not null, but I'm saying if it's not something that falls in that category. That's wrong. So this could be equals null or so if object kind is pointer and its type is null or the mark func is null, maybe that not needs to go back there. Okay. So if it's pointer and the type is null or the mark func is null, but we're doing the opposite of that. So the problem here is if this is false, then it makes the whole thing true, which we don't want. So let's do this first. If that is true, I think I'm doing the wrong logic. I don't know what I'm doing wrong here. Maybe it was right to begin with. So object kind is pointer. Yeah, I don't know. I think maybe it was the wrong logic. I had it the opposite to begin with. So let's do this. It's not null and are we checking that correctly? No. What the hell am I doing wrong? So right. Okay, I missed that one. So if object kind is pointer and it has a type and the mark func is not null, then we need to go inside. Okay. So this is probably what the problem was. All right, so we're about to free a couple of native pointers here, which is not correct. You know, I think there is an issue with the logic. Maybe this one should be first, because the rest of them are basically saying if the kind is not... Oh, okay, so these are ands. This is complicated. Let's do this. I think this may be another thing we need to think about. So what I'm doing is saying if it's not a pointer type, then or any of these other things, then go inside this. Otherwise, if it is a pointer type, then check to make sure that it has the necessary things we're looking for. A bit more complicated than I would hope. Okay, there we go. I think it's working fine now. Well, that was exciting. As Ashraz noted, I said, yeah, I guess it's working fine now, and then it crashed my entire desktop environment. So I don't know exactly what happened there. It might happen again. Let's see what happens here. I'm going to try to pull up the project because it totally knocked away all of my working state. So we're going to run compile and try to run it again. This could cause another crash, so if it does, I'll just jump back on the same stream, and hopefully we'll be back up again. So let's see what happens. Yes, place your bets. Place your bets. I don't know if I take up all the video memory and that's what happens. But I don't know. It seems to continue working, so. And then it crashes again. No, I'm just kidding. All right, so checking object pointer for Mark Funk. Well, it's doing something. And I think it's keeping the system. It's not throwing it away. I don't see it freeing it, which is good. So what if I kill it? Could it be that messages get a little bit too much in the compilation buffer? I suppose it could. It's not so many. I mean, it's only 1,500, so hopefully that's not it. I think it must have been a video driver crash because I'm doing a few things here. So let's see. About the darkened pointer, about to mark particle system, checking object pointer from Mark Funk. Where are we when we do that? We need to go back to projects, code, siphon break. Depths. No. Yeah. Substratic. Engine. Source. Whoops. Source. Particle.c. Checking object pointer from Mark Funk. Oh, okay. Adding pointer to Mark stack. Checking object pointer from Mark Funk. Cool. So I think that is fine. So we do have a Mark Funk in one place, which does make sense about the free native pointer, blah, blah, blah. And it didn't crash, and it didn't complain about memory leak, which is a good sign. I think that means I've caught everything. So I can even, let's see, the free funk source particles, that's fine. That's working great. And then this one, I think, can go away. We don't need this now because we're freeing the related object using the GC. So for particle system type, I can take the free funk out. So that memory location is probably because I'm using a statically defined struct. So it's coming from this struct, or was it system type right here? So this Mark Funk. So since it's statically defined, I'm guessing it's because it's in a different segment of the process memory and not in the actual heap. So that's my assumption as to why that address is low as it is. And it is getting called correctly. So because we see about to mark particle system. So it's being called. So I think we may have made it to the point now where we're garbage collecting, or at least we're marking correctly so that it's not going to crash the game anymore. We're flying around, particles are sparkling. So that's great. So now let's clean up some of that text. I don't want to see all that stuff all the time. Go back into the mesh compiler source. And let's look at the changes. Not the game. I don't know what I said that was referring to. So this part I can delete now. I can take that part out. Let's see, call the pointer's own free function if there is one. Oops, not that. That. Will not crash the game. Yeah. It might crash my entire system, but you know, that's a whole other story. Okay, so let's see what else we got. That's good. I might check this in a moment. That's okay. That needs to be cleaned up. In fact, that can be taken out entirely because that was just a diagnostic. And everything else looks good. Take that out. And then this about the darken pointer can go. Let's make sure everything still runs correctly. Just fly around a little bit, shoot some things. Pick up that speed boost. I think we're good. And then I'm going to use up all my energy. Boom. Play again. No. Press Q to quit. Everything's clean. Good. All right, I like it. So let's check this code in. That all looks good. All right, so object VM, make it possible for object pointer to be marked and freed. Yeah, just be marked in GC. Trying to be a little bit terse here. Origin. Oh boy, I have to change the remote. Fantastic. All right, so let's change the URL. Git at github.com :mesh_lang/compiler. Now we'll push that to origin. Not prune ref specs, dude. Come on. I don't know why it keeps doing that. I think it wants me to type in my passphrase, and I killed the pin entry prompt. So who knows when that's going to pop back up again. I'll push that later. Okay, so now let's go back into Substratic repo. And I think we can check this in also, just to have it there and ready. Everything else is kind of clean, I think. So I'll check this in. So particle, mark subst particle system and sources correctly with GC. Okay. So I'll push this later. Now, the next phase of what we're going to do here is, oh, here we go. All right, so now maybe, okay, that push did work, and now I can push this too. Great. The next phase, what we want to do, projects, sites, flux, content, live streams, 26. We fixed this issue. Now, let's go with opacity first. So for opacity, let me look at what we've done in module substratic particle. So color interval, I think we also need an opacity factor here. So color, well, I guess the question is, does opacity factor into color, or should color just be the RGB channel, or should color be HSV, because that might be easier to interpolate? I think opacity should potentially be separate, because it's something that you might change at a different rate. So opacity would be one. Opacity, geometry, color, opacity, size. I put color there because color is not the same type of factor. So maybe opacity can be next. So size, color, opacity. And that means that in the source code for particle.c, I need to go change a couple things here. Color, float opacity, and we need another factor for opacity here. And if you're not familiar with the term, opacity just means how transparent the particle is for it to fade out effectively. All right, so particle system, all good. I need to go to where I'm pulling in these values. Read particle factor. Excuse me. Long day. So opacity will go here. And that will be a range. So the next one was size and opacity. Cool. So that's fine. Now opacity should start off as 1 value. So I wonder if I need to have a default value in this factor function. Read particle factor. Haven't thought about that yet, but we probably do need some concept of defaults. Or here I could just say or opacity 1.0, I think. That way we don't need to do anything special. And then question is, what does opacity mean? It would almost be like a velocity, like how fast does it fade out? So maybe opacity is not the right term for this. Well, let's start with the name opacity, then we'll change it. I just want to get it working because we are running out of time. So if I have the opacity factor, update, I think I have update here. Is opacity linked to leftover lifetime? Yes, it would be. Basically, the amount of time the particle has been alive will dictate the opacity, I think. And that is time left. So it'd be the inverse of time left, I think. So if you take, yeah, we might need a total time to calculate that correctly, even. So time left, or if I just divide it by 1 divided by time left, I think that would be right? So 1 divided by, let's say, 0.5 is 2. I don't know. Is that right? Might be able to make that work. So if time left is what, 10? Let's say it's 5 seconds. 1.0. 0.2, 1.0 divided by 1 second is going to be 1. What about 10? Yeah, I'm not sure. I might be wrong about that. So we may need a lifetime and a time left here to do the right calculation, but we'll add it if we have to. So for, we definitely want opacity here. We want that to be a 0 to 1 value. So when we initialize a particle, subst particle, where am I doing the malloc on that? Whoops, I shouldn't have let that in. Okay, so this is where we're allocating the particle list. Let me add opacity here. Just a little reference. Make pointer type. Okay, linear factor time left. Yeah, that's that might be useful. Thanks, Ashraz. Let me take a look at that. That's okay. I understood what you meant. Where we particle equals. I need the particle initialization, so this would be right here, right? Update existing particles. Has the creation interval passed? Okay, so this is it. Set particle factors, particle opacity. Come on now. Opacity equals 1.0. It's a float, I think. Let's put it right there. Okay, so we start, let's assume that it starts at 1.0. We might actually have to set a default value to something else. But we have opacity there. And then in the update for the particle, we also have here add fade. Update opacity. Now, that factor, I think that needs to be the thing that we are, it's like fade speed or something. And that could have a range. So let's just use opacity for that for now. So particle opacity. And where's the factor for that? In the source. Okay, so plus equals particle source opacity. No. Right, okay, yeah. Let's just start with this for now. So times, let's do a minus and do a max of 1.0 and opacity max times particle opacity. So we're gonna fix this because all this doesn't make any sense, but I think that will get us started. Now, if I go back into particle.msc, I'm gonna change this to fade speed. I don't know if that's the right name for this. So we'll also say fade speed here because we're going to change it all. All right, so color, fade speed. And then back in particle C, let's look at opacity. So that's good. Float, fade, speed. In fact, we can just drop those on the same line since they're related. Make it more obvious. And then for factors, this is going to be fade speed. This could even be down here. And then opacity, whoops. Read particle factor. Let's go down to this set. And then fade speed. We're going to read in. Okay, so now that's feeling a little bit better. Fade speed. All right, so we start up opacity at 0, or sorry, 1. That sounds fine. Update opacity, particle opacity is max, particle fade speed. Now, we also need to initialize the value of fade speed here based on this particle factor next value, because that will randomize the fade speed of a given particle based on a range, if there is a range. So we can do this, ampersand source, fade speed. All right, so particle fade speed. So that should set that up. And we also need to update the renderer to fade that particle. So we need to change the color as we do this. And I think it's relatively safe to edit that channel in place. Just needs to be reset correctly. I think we can do that. Okay, so particle color dot A equals particle opacity. And I think these are 0 to 1 channels, if I'm not mistaken. So color.a, set the color opacity. Draw the particle. All right, let's see if that actually works. All right, got a little error here. No member named opacity. That's fine. Line 209. Particle opacity source. Okay, yeah, this is wrong now. Particle fade speed. Come on now, particle. Can we type? Particle fade speed times. Interesting. Let's change that to opacity then. Oh, hold on. Wait. That's not right. That's fade speed. Fade speed times time delta. Because it tells us just how fast the fade happens. And then we're multiplying it by time delta to get the amount of fade for that frame. So that should work. All right, let's do that. Oh. That's wrong. That should be 0. So we're fading it, so we're going to leave that, whoops, max of 0 here. Let's do that. Undefined reference to max. I need math.h. Say what? Oh, can't be right. I must have math.h in here somewhere. Yeah, I do have math.h in here, so what's the deal? Bunch of other random code. Can I just see what's in my own code, not this inlined source? I know I must be calling max somewhere. Oh, is it because it's a floating point value? Where am I using that? In mesh, compiler, source, math, max, fmax. Okay, so fmax would come from potentially math.h. Go back to particle.c, fmax. Okay, that seems like it was happy this time. Oh, haha, the fade speed is way too fast. All right, so it is fading out. And it needs to not be set to start with. So how do we update that? We need to set that factor. Let's go back into particle.msc. If fade speed is 0, then it doesn't fade. So what if I do that? So, or fade speed 0. And then, so opacity goes negative immediately. Max 1.0x will at least use x. Okay, I'll take a look at that in a second. Okay, in particle.c, we read in the factor, read particle factor. We shouldn't apply it if it's 0 to begin with. All right, so then that needs to be in the update logic, fade speed. Fade speed right there. If particle fade speed is greater than 0.0, then you update it. Otherwise, you do not. If there is a fade speed. So currently, we're not setting a fade speed on the particles on the ship. And the fact that it's doing that is not a good sign. Let's see. Printf, updating, particle opacity. I want to see why we're getting garbage here. Because we're definitely getting some garbage. Yeah, we shouldn't be doing that. And what is the fade speed? It must be garbage. Particle fade speed. We're not setting that yet. Am I not initializing that correctly? Let's see. Yeah. All right, so it's kind of random. So fade speed equals particle factor next value. If how about this next value? If factor min equals factor max, then return factor max. Otherwise, return the random double. Let's see if that does anything. Probably not. Okay, so we still get some BS. All right, so particle, read particle factor. Min as number min, max is equal to min. Printf set factor to factor min. So, ooh. Yeah, okay. Set factor to 0. which should be right because we're setting it to 0 to begin with. So something in my code is not initializing this correctly. Fade speed. Opacity equals 1.0 f. Then factor min max. Let's put max. Shouldn't be 0 to begin with. Same value, 0, 0, 0, 0, 0. Okay, so that all is looking right now. All right, so there's a calculation I'm doing wrong then. So then updating the opacity. Opacity is 1. If fade speed is greater than 0, updating particle opacity. I don't understand. Why it would be writing out. Whoop, hold on. This needs to be F. Am I missing some precision? Oh, wow. Why is it those values? That's not right. I think I did something wrong. Particle next. Let me show you what I did wrong here. Next value. That's what I did right. No, that's it. It's right. So how am I setting fade speed wrong? Ah. Bad ordering. Shouldn't have moved that. All right, there we go. Now it's correct. We're not updating the opacity. So the reason why this is a problem is because the order of these factors we're reading in matter because of the way that we're passing them in here. So because I'm passing in the fade speed factor after size, I have to read it after size here. Otherwise, it's going to get the wrong values. All right, so now we can go into the game code and set that fade factor. So system, not here, maybe it's in player. All right, so fade speed. How fast? Yeah, this is 0 to 1. Let's start with 0.5. It's gonna be very fast, I think. Okay, I see it fading. But it's not fading fast enough for me. Let's go with maybe 7. So it's per second. Let's do that. Okay, it's fading. Is that enough? I think it's fine, right? It's a good starting point. Let's go 3 and also take that updating particle opacity out of the code. Okay, that's I guess it does make sense though to also use the lifetime as a way to fade it, because it's sort of related. You don't want the particle to exist if it's not visible, right? So we could say it could fade. How do I handle negative opacity? I don't have a problem, or I don't have negative opacity. Because what I'm doing is I'm subtracting... Oh, hold on a second. Well, I am doing something wrong here. So this should be particle opacity minus, because I want it to lock to 0 once it's at 0. Okay, so There wasn't any visual issue with that before, but clearly that was wrong logic. Okay, so that's good enough for now. Let's see. We go mark that off the list. Opacity interpolation, color interpolation we'll add it another time. So explosion effect when a ship is destroyed. Now that one's going to be interesting. We can do that. We can do that for sure. So what we'll do is on enemy. Alive. Okay, so if it's still alive, otherwise do nothing. Oh, because right now it just disappears when it's dead. But instead of disappearing, it needs to explode, which means it needs to still stick around long enough for the particle system to finish. Unless you just let a random particle system hang around on its own, which I don't think we want to do. Let's see. Enemy. All right, so enemy, shield, enemy. I think we probably need an enemy state. So we can have, let's say, state here. Alive. Okay, so we have, for these two, their initial state is alive. And then we look at, is the enemy still alive if enemy shield... Isn't there already an implicit state via the enemy's health shield? Well, we need to also keep track of the state where they're exploding effectively. And right now, there's not a way in the particle system to tell whether the particle system is done. So we're checking whether the enemy shield is greater than 0, which definitely would tell you if it's alive. But if we also need to continue updating it and rendering it until the explosion is done, unless we replace that object with a different object that just shows the explosion. A little bit tricky. I mean, it's nice to not have another field to manage. And we can look at 2 factors, but let's see. How would I check to see if a particle system was done? I'd have to see if there had to be a total time for every source in the system, and they would all have to be past that time. But it still feels wrong to consult a particle system for that. It seems like it should be some other state. The particle system is sort of just a side effect of what state they're in. I mean, if you had a list of explosions that are not actually relative to the living object, then we could create one of those. And then that would be what lives. And then we wouldn't have any of the state of an enemy being updated. So that could be kind of nice, actually. Let's undo this. It does sort of raise the need again for some way to send events in the game engine. And we have like, let's say 5 or 10 minutes. So implementing basic eventing is not really what I want to do right now, but it's better than having some half-baked function for creating an explosion object in the game. So maybe yeah, there's probably another way to do this too. Especially if I was using a more component-based system, which I'm not right now. There must be a much more clever way to do this, but don't have time for that. Let me check and see what else we got. If I were to look at the list, speed boost effect. I mean, that one is a little bit easier to implement. Also, the burning effect for heat waved enemies, that could also work. But we need a way to have multiple particle systems attached. And then they need to go away at some point. Well, there could be one. That would be kind of weird if they all had the same particles. If I reuse the same particle effect on all of the burning ships. Okay, so let's think about the speed boost effect then. I want it to be some kind of obvious indication, like some green particles that are flying off. Maybe it's on either side. Let me just cook something up for that really quickly. So if we go into the player.msc, we have access to all the power-ups here. Speed is one of them. Speed power-up effect. Make effect updater. And then the renderer. So we kind of need some global system for this, which feels a little bit dirty, but it could be done in a pinch. So make speed power up effect, speed power up color, define speed power up particles. This is going to be nil by default. And then make effect, set current time. So that's the updater. We want the applicator function, make speed power up effect. This one is the one that needs to create the instance of that. So we're going to do that here. Set speed power up particles. And we're going to go to make particle system and paste that right in here. In fact, we could probably drop this down one line to break it up a little bit. All right, so max particles 40. We could say something different, like maybe 30. Geometry is player size. Size is, yeah, that's the size of the particles. We'll leave it the way they are right now. Fade speed 3. Let's leave it where they are. For the speed power up color, let's use the speed power up color. And the thing we want to do here is change the velocity y. It needs to be a static. Wow, this is a little bit interesting. Do I have the ability to set the initial position? Vel X. Okay, so vel Y, we're going to set that to 0. Or not set it at all. Because I don't want it to move. I want it to just go straight out from the sides. We'll see how that looks. That might be interesting. So we'll have to go catch one of these speed power-ups. Let's try that. See if it works. Oh, I haven't finished the implementation yet. I need to do, for the update effect, set current time. What is it? Particle system update? Yeah. Let's go back here, particle system update. And we're gonna put in the speed boost particles. With a time delta. And then we're also going to add a power up effect renderer. We're going to draw that speed power up here as well. So particle system renderer and the speed power up particles. We also need to set the origin. So particle system origin set player X. Oh, we need the system first. We need the speed power up particles. Player X, player, and then player Y player. I think that's the right thing. Origin set. All right. Okay. Let's see if it works. Now we gotta go catch one of these speed boosts whenever it shows up. Was that one? No. What's that? I don't even know what that is. That's kind of a weird thing to have happen, basically, where you add something in your code that actually causes your entire computer to crash. Or not really my entire computer, but it definitely took down my desktop environment. I think I must be running afoul of video memory somehow, and I'll have to diagnose that off stream. The window manager, the whole thing. I think something is crashing hard. I'm not sure what's going on. Let me just see if we can pull that up one more time and just double check whether the thing we added works, and then we'll call the stream there. And it might crash again, and if it does, we'll see what happens. All right, let's see if we can catch one of these. Oh, right there. Wow, so it's really interesting that it crashed my entire system, but there was an error. There's a normal error. So I don't know what happened at that moment. All right, let me do this really quickly. Function requires 8 parameters, undefined variable speed boost particles. Line 297 in script. I will be in player.msc. I need to get into projects code, siphon break, modules, siphon player. Was it 297? Come on now. 297. All right, particle system update. Speed boost particles. Speed power up particles. Speed boost. All right, so that's better now. Function requires 8 parameters. There's something somewhere else, which seems weird. Let's try this now. Come on, there we go. Okay, so I'm getting some sparklies here from the particle system. Interesting. Yeah, I like that. But it's not in the right location. Huh, okay. I think I know what's going on. Let's try this. Go back into player.msc. So when we set up the other particle system, what was it? The booster, there it is right here. So when we set the origin, we're doing it based on the location where the player is. So origin set. Let's go here and then dump this in. Actually, let's do that instead. and then speed power up particles. All right. Render the particle effect, and I think we don't need this rectangle anymore. So that should be good. Let's try it and see what it looks like. I think that we'll have to tweak it a little bit more, but that's a good starting point. Come on now, give me one. Boom. Oh, okay. Yeah, or yeah, I need to fix that. Let's do that. So we're not going to do the size +2. We're going to do minus. Same way we do the other axis. And we also need to tweak the effect slightly. I want it to go a bit further on the x-axis out, I think. So let's say 90 and 90. It's not bad, but I want it to come more off the sides, I think. So lifetime interval. Nope. No crash this time, thankfully. Did the stream stop? So let's see. I am noticing that I'm getting the benefit of the power up as soon as it shows up on screen. There's something wrong with one of these, I think. There we go. Let's grab that one. Boom. It's kind of interesting. Whoops. Try to siphon some people here so I can stay alive a bit longer. Oh, there it is. Boom. It's kind of cool. Actually, I don't want... I would like the system to not leave particles behind. So I kind of want it to always keep those particles on top of the player, unlike the booster particles that I want to hang around. So that's something that needs to change too. So let me add it to the to-do list. So if I need to go back to projects, sites, flux, content, live streams, there we go. All right, so speed boost effect, we added that. But one thing I do want to do is add an option for a particle system to always have particles follow origin. Because sometimes you want it, sometimes you don't want it. And I think that could be something that would make this particular speed effect look better. So unfortunately, the GC issue took a little bit longer than I wanted to today, but we did manage to make some progress, which is great. The game doesn't crash from normal GC scenarios. I don't know why the game is crashing in other cases and taking down the whole window manager with it. I'll have to look into that. That's a little bit scary. But otherwise, I mean, I'm pretty happy with what we were able to accomplish today. Next time, I don't know if you want to see particle systems again, but I think if I focus on anything, it might be improving the overall design of the engine to be a little bit more event driven, because there's a couple things I don't like about what I've done so far that I would like to change. So I might work on that. Or I might change to something different entirely. I don't know. I feel like the interest level in the streams has dropped a bit since I started doing the game development stuff. So let me know if you are watching or have been watching in the past and you're less motivated to watch the streams if it's just game dev, because I don't want to lose people by doing this stuff. I'm going to continue doing the game development regardless because I'm having fun with it. But yeah, I don't want to lose what few people I have watching at the moment if I'm only doing game dev all the time. Okay, so that's enough for today. Thank you very much for watching. We'll be back again on Thursday to continue where we left off. And until then, keep it creative. We'll see you.